At Gritt, we're pushing the boundaries of robotics by making it work in these unstructured outdoor settings. This has never been done before. Gritt's mission is to help civilization build infrastructure rapidly. For example, a construction site might take 3 years to build like a 900 megawatt power plant. With the Gritt systems deployed correctly, you could finish that in 6 to 9 months. If you look at other industries, right, manufacturing, agriculture, retail, all of them have seen a 1000% productivity boost since 1965. Construction has actually declined in productivity by 46%. Unlike factory settings or warehouse settings where you have perfect lighting condition, you're outdoors. You might be in the deserts of New Mexico, you might be in the winter of Maine, you will be in paddy fields of Texas. The material you're picking looks different every time with different lighting conditions. Because we take a software first approach, this allows us to capture data on the site and train our AI for any new elements we see or any other challenges we face on the construction site. If one robot learns about a certain behavior, it not just improves its own AI models, it can beam those models onto the other robots too. Recently, we trained it to pick up cinder blocks. It learned it in 2 days. We asked it to tie rebar, it learned it in 1 day.
This was driven from the fact that there is a lot of repeatable work that happens on construction sites. Robots, they've worked really well so far over the last 30-40 years in factories and warehouses where we can control a bunch of things. When you think of unstructured construction environments, all that goes out of the window.
Gritt's AI is a self-improving technical stack. We collect a huge amount of data from all of our deployments, all of our pilots, whenever the robot's out there doing real work.
Our approach here at Gritt when it comes to hardware is to try to keep things as simple and as off-the-shelf as possible. So you can think of our hardware as a collection of pre-assembled subsystems, submodules. They connect with simple attachments to equipment that construction firms commonly rent already. Things like skid steers, forklifts, bobcats. And since there's very little custom hardware required, it's really simple and fast to deploy Gritt on any job site.
Everything has culminated to this point where we have the capability, given the right exposure, and given the right deployments, and given the right framework. And that's what we are building here at Gritt.
So solar for us has been chapter 1, and it's been an amazing chapter 1 because it's a massive market, it's growing rapidly, and it's also an amazing playground where we can actually learn the skills that can transfer very well across construction environments.
We've done over 7 deployments, 400 panels first, then we did a megawatt, then we did like 5 megawatts, and we are getting close to hundreds of megawatts.
In just the next 18 months, our robots are going to help install more solar energy in the country than the US as a country used to install a few years ago.
50 years in the future, are we going to be picking up the cinder block and placing it by hand? Are we going to be picking up the solar panel and placing it by hand? Or will we have robots actually working alongside? We are enabling that future, which will allow us to build these things at a much rapid rate and be essentially a huge force multiplier to our workforce today.